Hi everyone, this is a review session to help you prepare for science. Let's discuss the structure of the exam. The exam is made up of 20 questions. 15 of those questions are multiple choice. It is for 60 marks, so each question is worth 4 marks. The second section is made up of free response questions. That means you will write your answer. There are 5 questions and it has a total of 40 marks. That means that each question is worth 8 marks. In school, we are focused on the written response questions. Please make sure that you study them and you are able to write full sentences using that vocabulary. Okay, so let's start now with reviewing the multiple choice questions. In part 1 of our paper, the first question will come from page 12, and it is only about the picture. So please make sure you study this picture completely. Okay, they may ask you the question in one of two ways. They may ask you to name the numbered part, or they may give you a description of the landform and ask you to give the number or the letter that represents that description. So remember, it is multiple choice. It is important that you know the spelling of the words and where it is on this map. They will change it because multiple choice is only A, B, C, and D. 2 of these will not have a letter. We don't know which one, okay? So make sure that you know all of them. Let's look at how we can remember them. So we have our big, tall landform over here, which is our mountain. We all know what is a mountain. Our jebel, mountain, right? So our mountain is something we can all say we know. Another thing we all know is our river. A river is moving water. Then we have our ocean. Our ocean is a large body of salty water. So we can say we know our ocean, we know mountain, we know river. So the ones we need to focus on are canyon, plateau, and coast. So let's talk about the canyon. A canyon is this steep side valley. So it's a valley, it's between two mountains, we can see that, but it is a U shape, not a V shape, because it is very steep. The sides go down quickly. So this canyon is a steep valley. The top area, if we had to draw a box, it looks like a table. That top area is called the plateau. It looks like a flat, high land. So it is land that is high and flat. Flat kind of looks like plat, right? If we turn this into a P, plateau. So our flatland is a plateau. Then we have our coast. Coast, it's also with a C-O, but canyon ends with on. Coast is st, okay? So please make sure you learn the difference between these two words. The coast is that small area of land between land and water. So when there's water and there's land, the land on the edge separating the water and the land is called the coast. Okay, so some questions they may ask you. All of these that we just reviewed are called landforms. They may ask you which letter represents the mountain or the plateau or the ocean or the canyon or the mountain or the coast, sorry. So you will have to know where each of these are. You should also try to learn what they are: high above the earth, steep sides, flat plateau, remember our P, plateau, water and land is our coast, moving water is our river, and salty water, our ocean. Please make sure you review this and you are able to identify everything on this picture. Now let's look at the second question. The second question and the third question come from page 17. Okay, so let's look at page 17. This picture is showing us a topographical map. A topographic map is a map that uses these lines, and these lines are called contour lines, and they show us elevation. Elevation is how high something is above the sea. When these lines are close to each other, it shows us that the land goes up slowly. We use the word gradual. When the land goes up quickly, this one over here, we call it steep. In grade 2, you learned that this is called a slope. So when my slope is steep, it goes up very quickly, it will make a mountain and the lines will be very close to each other. When the lines are further from each other, the land goes up slowly and we call it gradual. Our slope will be gentle when the lines are further. When the lines are closer, they are steep. A plateau is something interesting because the top of the land is flat, right? But it goes up very quickly and then it's flat. So this area where it goes up very quickly, you will see the lines are extremely close together. Now let's look at the bottom of the page. On the bottom of the page, we have these two pictures over here. You need to know the pictures and the words because there will be two questions on the page and one of them is about the pictures. It may be the picture of our topographic map or it may be about latitude and longitude. So scientists developed a system where they took the Earth and they made lines going down and across. And we use these lines to show us the location of an object. So the lines going to the side kind of looks like an equal to sign. And we call those lines lines of latitude. So latitude lines go across and they show me how far north or south something is from our equator. Lines that go long are called longitude, and they show me how far east or west something is from the prime meridian. Here are some possible questions you may get from page 12. You can pause the video and review the questions. Okay, so the map that uses our lines is called a topographic map. The landform where the lines are closest together is called our plateau. Okay, so remember our topographic map. Our latitude are the lines that look like equal to signs. And longitude are our long lines. The word to remember with longitude is prime meridian. But easier to remember is latitude is these lines and they look like an equal to. Okay, again, here are some questions you may get and you may pause the video and review them. Okay, please take a moment to scan this code and try these questions on our quizzes platform. Once you are finished, continue the video and move on to the next section. Okay, now we're going to go to page 34 and talk about Earth's forces. Okay, so in this page, we can see that they discuss forces that shape the Earth. They mention volcanoes, earthquakes, and the flow of rivers. In this section here, they mention that volcanoes change the Earth slowly. And they do this because remember our volcano is an opening in the Earth, as our lava comes up, it becomes hard, it makes new rock, And over time, like a stack of pancakes, it will build up land and eventually make an island. So volcanoes will make an island. But it happens very slowly over time. Something that can change the earth very quickly is when an earthquake happens. An earthquake happens because there is a sudden slip of two plates. Remember, the place the plate meet is called a fault. That is our break in the earth's surface. And when it slips, it can cause our earthquake. And when it slips, suddenly it can make S shapes, S-shaped folds in our rock. So here are some possible questions you may get. You may pause the video and review the questions. Right, now let's move on to page 49. This page speaks about two things: physical weathering and chemical weathering. So let's remember, what is weathering? Weathering breaks it, erosion takes it, deposition drops it. This is the song we learned to remember it. Weathering breaks rocks. There are two ways that a rock can break. One is physical. Physical is when something breaks the rock. For example, over here we have them discussing animals and plant roots. Animals and plant roots can break the rock physically. Okay, the question on this page asks what kind of force causes abrasion? And our answer is gravity. Gravity causes rocks to fall down and hit other rocks. And as they do this, the rock becomes smoother, which is abrasion. Okay, so we already spoke about physical breaking of rocks when something smashes a rock into smaller pieces. Now let's talk about chemical breaking. Ch in the beginning of chemical reminds us that the word means change. So chemical is when the rock changes. And if the rock changes, then we have chemical weathering as it breaks down. Okay, so the rock can break because of a few things: water, living things, and oxygen. Acid is one of the main things that cause rocks to break down. These acids can come from things like volcanoes or from plant roots or lichens. This picture shows us an example of a lichen that makes acids. So acid breaks rock. And it breaks it by chemical weathering. It changes the rock. Changes. The other thing that can also break the rock with chemical weathering is iron. Inside of rock, some rocks have iron. It's a mineral. And this iron joins with water and oxygen. So it joins with oxygen and water and forms a new thing called rust. Rust is very crumbly and soft, and this breaks the rock. You may pause the video and review the questions on page 49. Okay, now let's move on to page 50. We spoke about weathering. Weathering breaks it. Now let's speak about erosion and deposition. Weathering breaks it, erosion takes it. Deposition drops it. So what is erosion? When something is taking it, it is moving the material. It moves the broken piece of rock from one place to another. Deposition drops that rock into a new place and changes the land. So erosion and deposition work together. Let's look at gravity and how erosion and deposition can move with gravity. So gravity causes things to fall down, usually down the slope of a mountain. If there's a lot of earthquakes or rain, it can cause a landslide where these broken pieces of rock start to slide down the hill. And as they do this, they can change the shape of the land. Another way that erosion and deposition can happen is by running water. That means rivers, moving water. Okay, so when water moves in a river, if it is steeper, that means the land goes up more quickly, then more weathered material will slide down. Okay, it will be more fast and it could end up causing a lot of landslides, and it could cause sediment, our pieces of rock, to build up, making a delta at the bottom when the river drops. Another way that we can get erosion and deposition is by wind. Wind blows the sand around and eventually drops it to form sand dunes. A sand dune is a deposit of the wind-blown sand. So the sand dune itself was made by deposition. The wind moved the sand to make it. So wind moved the sand, and the deposit, the dune itself, is called is formed from deposition. So deposition makes the dune. Okay, so one important thing to remember: how can I keep the dune from moving? How can I prevent erosion? Well, I can plant a tree because its roots are like little fingers that will hold the sand in place. Okay, so the roots of the sand, if I plant trees, can hold sand and keep it from moving around. Remember, we learned the word vegetation. So here are some possible questions from page 34. You may pause and try and review these questions. Okay, please take a moment to scan this code, pause the video, and complete the questions on weathering, erosion, and deposition. I know there are quite a few in this section. You may try this over 2 days and maybe watch the video again tomorrow and try the other 2 sections. Okay, now let's review page 85. On this page, they will only ask you a question about this picture. They may change the numbering a little bit, but it's very unlikely. So let's review what we have. This picture shows me these blue lines, which are called plate boundaries. The plate boundaries move together, they can move away from each other, and they can slide past each other. And when they do this, they cause earthquakes. The question is asking you to look at this picture and say, where do you think most earthquakes will occur? Will they happen here at number 1, 2, 3, or 4? Well, most earthquakes happen at the plate boundary. So look for the number that is on the blue line, and that number is 1. So 1 is the place that most earthquakes will occur. Okay, let's go on to page 101. This page is all about reading and interpreting information from a table. So you will have to read this information and answer questions about it. Okay, so when we look at this table, we can see that the table is telling me about earthquake data in California. It gives me the year this happened over here and here. And in the last columns, it tells me magnitude. Remember, magnitude means the size of the earthquake. So now I know that I have the year it was and the magnitude, the size of the earthquake. Location tells me where it happened. the place. They may ask you any question about this table. I have just made a few examples. So let's look at the first one. In which year was the highest magnitude earthquake recorded? Okay, so I'm going to erase this and we're going to look at how we would read the map. So number one, identify what the question is asking you. They want to know highest magnitude of earthquake. So you need to find this something from this section. They want to know the magnitude. Highest means the biggest. So which number is the greatest? So when we look at our numbers, I go down it quickly and I can see the numbers in 7 are the greatest. There's 7.8, 7.1, 7.2, 7.2. The greatest is 7.2. But they did not ask me just for the greatest. They said in which year was the greatest magnitude. So now I need to go across to my year, and my answer is 1906. In the second question, again, they are asking me about the year. So again, the answer will be from here. So in which year was the lowest? Lowest means the smallest. The smallest magnitude earthquake recorded. So again, look through your numbers and you can find that the smallest number we have is 4.9. There is no number smaller than 4. So the year that it was recorded is 1920. Okay, another question. Which decade experienced the most earthquakes? A decade is when we count our years in tens. Okay, so for example, we would have 1900, 1910, 1920, 1930. All of the numbers that come in this decade is, all the numbers that are like in the 1900s would be in the decade 1900. If it is in 1910, like 6.5, that's in the decade 1910. So we are going to look for where do we see in the tens place repeating numbers. So look at your tens place, and in the tens place, we're going to look for repeating numbers. And we are looking for the one that has the most. So 1906, it's only one time. You can see here we have the 20s, we have it 2 times. The 30s is just once, 40s is once, 50s is once. 80s, I see it 3 times. 90s, I see it 2 times. 2004, only once. 2010, only once. Okay, so which number do I see the most? The 80s. So my answer is the 1980s. Question number 4 says, what pattern can I identify in the intensity of earthquakes? I see a mistake with my question. It's supposed to be, what pattern can you identify in the intensity of earthquakes? Or can you identify a pattern in the intensity of earthquakes? Sorry about that. Okay, so can you identify a pattern in the intensity of earthquakes? Can you see any pattern in the intensity, the biggest earthquakes? So let's look again at the biggest earthquakes. Okay, so take this away. The biggest earthquakes were 7.8, 7.2, 7.1, 7.2, 7.3, and 7.2. So let's look at when they happened. They happened in 1906, 1923, 1940, 1980, 1992, and 2010. Most of these years are about 20 years apart. So I can tell that every 20 years, stronger earthquakes happen. Okay, so I gave you an example of if they ask you for the year, but if they do not ask you for the year, then you will not see the word year in the question. In this question, it just said greatest magnitude. There is no word that says year. So what was the greatest magnitude recorded? we are only going to give this answer, not look anywhere else, and that is 7.8. Okay, now let's go to page 97 and talk about the instrument that measures the earthquake. So this is called a seismograph. A seismograph is used to detect and record an earthquake, and it will make these curvy lines to help us see the earthquake. If it is steeper lines, it shows us that the earthquake is stronger. So over here where the lines are closer and higher up, they are stronger. Where it is a gentle line and further apart, it is weaker. So the minute it goes up, it becomes stronger. The word we use to describe the strength of the earthquake is also the one that tells us how much energy comes out of the earthquake, and that word is magnitude. So magnitude tells me how much energy an earthquake releases. The scale we use, we can use two scales to measure an earthquake. One is called the Richter scale, and it uses numbers. These numbers are whole numbers starting at 1 going up. So 1, 2, 3, 4, etc. The scale, we saw this being used in this section over here, where you see these numbers. That is our Richter scale. Okay, the difference with the Richter scale compared to the Mercalli scale, the Richter tells me how much energy comes out. The energy from number 1 to number 2 is not just 1, it is 32 times more energy. So between the number 1 and 2, or 2 and 3, or 3 and 4, each one, it jumps 32 times more energy. The Mercalli scale, on the other hand, does not tell you about energy. It tells you about what people feel in the earthquake. And it uses Roman numerals. These are letters that look like this. And it tells us how they felt and what happened. So how many buildings were damaged, did it fall down, that kind of thing. Now let's look at the picture. You may be asked to identify things in the picture when we see the first lines where it is wavy. This is our longitudinal wave. We learned that this is the wave we feel first. The wave we feel after is our transverse wave, and this one causes the most damage. You can see the longitudinal wave is very small compared to the amount of energy from the transverse wave. This is a lot of energy. So questions you may get is, where is the magnitude of the earthquake the greatest? And that would be amplitude. The amplitude is how high up our wave goes. Remember, amplitude is the height of the wave. So the higher the amplitude, the greater the magnitude, the more strong the earthquake is. So over here, at this point over here, I'm going to make a star. This is where our amplitude is the greatest. So the earthquake has its strongest magnitude at that point. Okay, here are some questions you may be asked in the exam. Okay, please scan this code and give the questions in quizzes a try.